So the first thing you're doing today is you're writing this into your notes. Now this should look a little bit familiar. You have already been using this year. I gave you some WOMAT questions where I was having you evaluate the formula, and it was this formula. I was just giving you the values to plug into it. And so that was all with numbers. Today we're going to be taking it one step further, and we're going to be doing problems like these, where you're given one of the values, but you're not given the h value. And we're still going to be able to evaluate and simplify the whole thing. So start out, please, by writing down this problem, and then we're going to work through it step by step. So the idea here is that we're going to be using this formula for f of x here in order to find these different values over here. Now, to start with, I want to go ahead and tackle this f of 2 plus h. So notice we're given that a equals 2 in this particular one. So I want to figure out what that means, what that equals. That requires us to take that 2 plus h and actually plug it in for x everywhere where we. And so this is what that's going to look like. The f of 2 plus h is going to be written like that. And so you'll notice all we're doing is taking 2 plus h, and we're plugging it in everywhere where there was an x before. Just replacing those x's with the 2 plus h. And I'm only doing this one piece right now. It tends to be a little bit easier if you just take it piece by piece, especially at first when doing these problems. Alright, so the first thing I want to do with this then is go ahead and start simplifying this expression. So I distribute in the 4, and that gives me the 8 plus 4h, and then I'm going to have to actually square out this 2 plus h. Now take your time with that. Remember, 2 plus h squared is not 4 plus h squared. We actually have to do 2 plus h times 2 plus h, which gives us 4 plus 4h plus h squared. Now as you look at this, you'll probably notice that I left it as minus and then the parentheses there. That's on purpose. If we try to do too many pieces all at once, we tend to lose something. And as you probably already noticed when we were just plugging in the numbers, if you lost a sign, you basically had to go and redo that whole problem. The same kind of thing will happen here. So take your time, show the extra steps, and actually do minus the parentheses before you distribute that negative in. Because if you then distribute in the negative, then you know it's right. And you're not going to have to do the same problem 5 times and feel like you're beating your head against the wall in order to do it. Once we got to this point, then you're just going to be able to combine the like terms. And so when we combine the like terms, the 13 minus the 4 gives us 9. The 4h minus 4h, that just adds to 0, and so they cancel each other out. And just that minus h squared is left behind. Alright, next up we're going to tackle the f of 2. Now in this case, since it's just f of 2, we're just plugging 2 in for the x's. Which means that by the time all of this is said and done, we should have an answer that is just a number. So plug in the 2 and calculate what that gives you. Alright, so when we simplify that whole thing down, the f of 2 just equals 9. Now, I went ahead and broke this up into those couple pieces there because it made it easier to do all this arithmetic and the algebra separately. That way I'm not trying to do 20 different things at once. I'm only doing 3 or 4 things at once. But we do need to be able to put all of these pieces back together into this one big expression. So, take those pieces and plug them in. We figured out that f of 2 plus h was 9 minus h squared, so we plugged that in. And the f of 2, that just becomes 9. And so then, it's a matter of simplifying this resulting expression. So if I have 9 minus h squared minus 9 on the top, well, notice I can simplify that a little bit. So let's simplify it. Notice those 9's combined, although very conveniently at that, because we end up doing 9 minus 9. That just leaves us with negative h squared on the top, because 9 minus 9 was 0, obviously. Well, I don't want to leave this as my final answer, because I can still simplify it even more. So negative h squared over h, that would just equal negative h. And so the whole thing ends up equaling a negative h. And so this is our final answer for this. This is our difference quotient. This is what it equals. The whole thing actually just evaluates down to be a negative h. Now, I didn't get into the application of difference quotient today. We're just seeing what the expression is and seeing how to use it. We'll make sure we're comfortable with that, and then we'll start plugging it in and seeing how it actually ends up getting used, but building these foundational skills so we aren't having to juggle 3 different things all at the same time. All right, so we now switch topics a little bit, and we're now taking a look at whether a function is considered to be even, odd, or potentially neither, because not every function is even or odd. And so we're going to be looking at that for both of these two functions. Okay, do you remember what makes a function even or what makes a function odd? Well, hopefully you would, but I realize it's been a little while. So if you're a little rusty on here's our notes, here's our definitions of an even function and an odd function. Add these to your notes if you didn't remember it right away. All right, now a few little details about this just to make sure what you've written down to your notes is clear. The first one says the graph is symmetrical around the y-axis. So for instance, if I have a parabola, is that an even function? No. Oh, trick question. The answer is probably not. It's only an even function if the y-axis actually goes through the vertex. If it doesn't, like let's say it looks more like this, then it's not even. It has to be symmetrical about the y-axis. So exactly the same on the left as it is on the right. Okay? The other thing to note here is the f of negative x. And this is really going to be the big test that we use on most of these. Is if we plug negative x into the equation, what do we get out? Because if we get out exactly what we started with, then you know it's even. Basically it's saying if I plug in a negative number, I get the same as I do with the positive number. In other words, same on the left as on the right. Odd function, yeah, it's rotated, but notice here, if I plug negative x into the function, it means I'm going to get the exact same thing as the original function, except the whole thing has had its sign flipped. All right, now let's actually see how this gets applied. Going back to the two functions we wrote down earlier. In order to test this, I actually want to plug in negative x, where x is. So that's going to be my very first line of work here. And so when you put that in there, you're going to write this as f of negative x, because of course we've got to keep track of what we plugged in. And then, in parentheses, put the negative x squared. If you leave off these parentheses, as you know, it means something different, and it's going to cause you trouble as you go forward with it. So this is what we're really evaluating. We're doing a negative x squared on top. We're doing a negative x to the fourth on the bottom. And we need to see what each of those gives us. So on the top, what does negative x squared equal? It's x squared. Yeah, because remember when you square something, it always gives you a positive answer. So regardless of whether x was positive or negative, you're getting a positive x squared out of it. What about on the bottom with that negative x to the fourth? What would that equal? Yeah, that'd be a positive x to the fourth. And so this is our answer when we plugged in the negative x. Now, since that's what we got for f of negative x, we now take that final result and we compare this to our original function. The first thing we look to see is it exactly the same? Are they exactly the same? Yes, they are 100% the same. Every single little piece of it. And yes, every piece has to match up. Therefore, since they are the same, it is even. Because we just proved that f of x equaled f of negative x. And if you were asked to justify it, if you were asked to give a reason why you know it's even, you would do this work, and then you'd make this statement. Having done that one, take a moment, give that a try now with the second function. So we plug in negative x for all of our x values. And so we see what that's going to end up equaling. So we do f of negative x equals, okay, we got 1, and then it's going to be plus 3 times negative x cubed. What is negative x cubed? What does that equal? Negative x cubed, absolutely. And so it's like, instead of being a plus, it's like we're making this a minus 3x cubed then. Because it did flip that sign. Okay, now, what about this minus and negative x to the fifth? Negative x to the fifth equals negative x to the fifth, yes. The negative inside does not get canceled out by the fifth power, of course, because it's odd. And so it's like our minus becomes a plus x to the fifth. All right, so we plugged in negative x. We simplified it. Now we compare it. So taking a look at this expression right here, is this exactly the same as what we started with? No, it's definitely not exactly the same. So then we next look to see, is it the same except the function is negative? That is, we flipped all the signs. Is it? No. And this is actually one of the trickiest parts, because a lot of you are probably looking at it going, yeah, it is. Because look, it's negative and it's positive, and it used to be positive and negative. But what about the 1? Notice the 1 is still positive. Because that 1 is positive, no, it does not equal a negative f of x. Every sign would have to be flipped in order for it to be able to be the same. And so this one's neither.